All right, honors chemistry people, we are going to do some more moles today. Hopefully you're good and safe at home today. So let's start off where we left off. We left off doing moles of iron oxide last time, iron 2 oxide. Today we're going to start with this question right here. How many molecules are there in 720 grams of glucose? Glucose is C6H12O6. Hopefully you remember that from biology and your photosynthesis cycle. The very first thing that we have to figure out is what is the molar mass of glucose? So let's look at glucose. We've got 6 carbons, we've got 12 hydrogens, and we've got 6 oxygens. So we're going to look at this. Carbon, we know we need 6 of them. So we're going to grab our periodic table here. We're going to look at carbon. Carbon right here gives us 12.01 grams per mole. So let's get back. So we have 12.01 for carbon. Now we look at hydrogen. We've got 12 of those, so we've got to multiply our mass of hydrogen. Let's look at hydrogen. 1.01 to the 100th, so we'll use that. 1.01. And then last but not least, oxygen. So let's look at oxygen on our periodic table. So if I look at oxygen, I've got 16.99. So 15.99 rounds out to 16, and I've got 6 of them. So I need to multiply that by 6. Okay, so take a minute with your calculator, add that all up, and when you come back, we'll check your answer. Okay, so if you look at this, we should get a molar mass of 180.18 grams per mole for glucose. Okay, now the next thing we've got to figure out is we are starting out with grams and we want to get to molecules. So if we're starting out with grams and we want to get to molecules, we're going to have to do 2 steps. The first step, we need to go from grams to moles using the molar mass that we just calculated. And then the second step, we're going to go from moles to molecules using Avogadro's number. So here we go. We have 720 grams of glucose. And we want grams to cancel. So we're going to use the grams of the conversion factor that we just calculated. We're going to put that on the bottom. So 180 grams of glucose will give me 1 mole of glucose. I'm going to kind of scrunch it together because I'm running out of room. Okay, so my grams of glucose cancel, right? I now have moles of glucose, but I don't want moles, I want molecules. So to get from moles to molecules, I have to use Avogadro's number. So moles are on the top here. So on the next step, I want moles to be on the bottom. So 1 mole of glucose will give me 6.022 times 10 to the 23 molecules of glucose. So my moles of glucose cancel, and I'm now into molecules, which is what I want. So I'm going to take 720, I'm going to divide it by 180.18, and then I'm going to multiply it by 6.022 times 10 to the 23 molecules to get molecules of glucose. So when we are all said and done here, our calculator gives us a whole bunch of numbers, but we only have 2 sig figs here. Remember, this last 0 is a placeholder. There's no decimal here. So when we round to 2 sig figs, we will get 2.4 times 10 to the 24th molecules of glucose. Okay? So 2.4 times 10 to the 24th molecules of glucose. So I can actually count the molecules that I have, which is pretty awesome. Now, this next one, how many grams are there in 3.5 moles of calcium phosphate? We haven't done one of these before. Notice we've got parentheses here. Do you see those parentheses? Now, parentheses in chemistry pretty much mean the same thing that parentheses in math do. The only thing that you're used to in math that is a little bit different than it is in chemistry, notice we've got this 2 at the back. Now, this 2 at the back is the same as a coefficient that we usually in math put in the front. So that means that everything in this parentheses is all multiplied by 2. So we put our coefficients in chemistry at the back. And you've probably noticed that already. We're kind of backwards compared to the math people. Okay? So when we look at calcium phosphate, that means that I have 3 calciums, because this 3, let me erase this box that I put here. This 3 only goes with the calcium. Okay? But this 2, because this phosphorus is inside the parentheses, this 2 multiplies the phosphorus. So that means I've got 2 phosphorus. And 2 times 8, we don't add. Remember, we multiply when we have parentheses. So 2 times 4 will give me 8 oxygens. Okay, so I need to look up calcium, phosphorus, and oxygen really quickly to get my masses. Now, we looked up oxygen already. So we know that oxygen is 16.00. Now let's look up phosphorus and let's look up calcium. So if I look up phosphorus, I've got 30.97 for phosphorus. So let's write that down for phosphorus. 30.97. Let's look up calcium. So calcium is 40.078. That's going to tell us to round up to 40.08. So 40.08. Actually, I need to multiply that. 40.08. Okay. We're going to add all of that up. So take a minute, stop the video, add that up. Okay. When you added that up, you should have gotten a molar mass of 310.18 grams per mole. Okay, how'd you do on that molar mass? Okay, the next thing we need to do is we need to see what that question is asking. How many grams are there in 3.5 moles of calcium phosphate? So I'm going to start with the number that is given to me, 3.5 moles of calcium. Actually, calcium, I can't write today. Do you ever have days that you just can't write? Calcium phosphate. Now, I don't want moles, I want grams. So I want to use this conversion factor to cancel out my moles. So that means my moles need to go on my bottom, on the bottom of the next step. So in 1 mole of calcium phosphate, I have 310.18 grams of calcium phosphate. Okay, so I'm going to take 3.5 and I'm going to multiply it by 310. And when my calculator gives me my answer, it gives me 1,085.63. Now let's look at our sig figs here. I've got 3 sig figs right here, And here I've got 5. So that means I can report 3 digits. So 1, 2, 3. This 5 is going to tell me to round up. Now, I could write this 2 ways. I could write this as 1,090 grams. That will give me 3 sig figs. Or I could write this in scientific notation. I could write 1.09 times 10 to the 3 grams of calcium phosphate. Okay, either one would work. Either one would give you the 3 sig figs. All right, let's go to the next question. Our next question, we are trying to figure out how many molecules there are in 8,050 grams of sulfur dioxide. Now, once again, we need to figure out the molar mass of sulfur dioxide. That's the first thing that we need to do. So if we look at sulfur dioxide, we have 1 sulfur, and I'm just going to put 1 here, and we have 2 oxygens. So we already know oxygen. Oxygen is 16.00. Let's look at sulfur. Okay, sulfur, here we go. 32.066. So if we round to the 100th, that will give us 32.07. Okay, so we're going to use 32.07. So when we add this up, 32.07 plus 2 times 16, which is 32, will give us 64.07 grams per mole. Okay, we're going to use that conversion. Now, we're going from grams to molecules. So once again, we're going to have to do a 2-step process. I'm going to need to go from grams to moles. And then once I have moles, I need to go from moles to molecules using Avogadro's number. So this is going to be a 2-step. Okay, so let's start with this. I have 8,850 grams of sulfur dioxide. Now I want my grams to cancel out. So I'm going to put my grams of this conversion factor that I just figured out on the bottom. So 64.07 grams of sulfur dioxide will give me 1 mole of sulfur dioxide. Okay, so my grams of sulfur dioxide cancel out. I have moles, but I want molecules. So to do this last step, I need to use Avogadro's number. I want moles to cancel out. So in 1 mole of sulfur dioxide, I have 6.022 times 10 to the 23 molecules using Avogadro's number. Okay, so my moles of sulfur dioxide cancel out, and I'm into molecules of that sulfur dioxide, which is what I want. So we're going to multiply 8,850. We're going to divide by 64.07, and then we'll multiply by Avogadro's number, or 6.022. Now, when we do this, our calculator spits out 8.31819 times 10 to the 25th. We've got, let's look at our sig figs. We've got 3 digits there. Remember, the 0 at the end without a decimal is just a placeholder. Okay. Here I've got 4, and here I've got 4. So I can really only report 3 digits. So 1, 2, 3. That 8 tells me to round up. So I am going to round up to 8.32 times 10 to the 25th molecules of sulfur dioxide. Okay, how you doing there? All right, last but not least, this is our last example. I've got 86.84 grams of lithium bromide, and I want to go to moles. So once again, my very first thing I've got to do is I've got to figure out the molar mass of lithium bromide. So that means I need to look at lithium on my periodic table, and I need to look at bromine on my periodic table. So I've got one of each. So lithium and bromine, let's look those up. So if I look at lithium, I've got, let's see, 6.94. Oops, that's not what I want to do. 6.94. And bromine. Let's see, bromine is over here. Do you guys see it? I have 79.90, so that will round to 79.0. So I'm going to use 79.0. 79.90. I keep misspeaking. Okay, so when we add that up, we get a molar mass of 86.84 grams of lithium bromide in 1 mole of lithium bromide. Okay, so we're going to use that conversion factor. I'm going to start out with the number that is given me in the problem, which is 86.84. Now, I want my grams to cancel. So I'm going to put my 86.84 from this conversion factor. Let's write that better. Come on. Will that not erase? Here we go. 86.84 grams of lithium bromide will give me 1 mole of lithium bromide. Okay. Now, my grams of lithium bromide cancel out. You'll notice that this is the same number, so it's going to reduce to 1. Now, the thing is, we've got 4 sig figs here and 4 sig figs here. So that means I need 4 sig figs in my answer. So how do I make 1 4 sig figs? I do it with zeros. 1, 2, 3, 4. So I'm going to need 3 zeros there. Moles of lithium bromide. Okay, hope this was helpful.